Hi everyone, let's discuss another Leetcode problem. Today's problem is problem 53, maximum subarray. The problem description says, given an array in integer array nums, we have to find the subarray with the largest sum and then return that sum. So what is a subarray? Subarray is the whole or the part of the array. So let's say this is my input array. So the subarray for this might be the whole thing, or it might be parts of the array. Say these three elements, this is a subarray, or these elements is a subarray. The condition is the elements needs to be contiguous. Okay, so this is like a subarray, or even every single element itself is a subarray of the array. So we have to find that subarray which has the highest summation. Okay, so let's talk about the solution approaches. Let's think about it, how we can do this. We can start with a naive approach, because the naive approach is always a good building block. So let's think about this. So obviously, all the array elements are not positive, because if they were positive, say 2, 3, 8, right? All we had to do is we had to add them all up, and that would have been the largest sum, right? So obviously there are negative values, which actually has the presence of negative value make the problem a little bit interesting. So how can we solve this? One naive approach is obviously to try all the subarrays, right? So you see let's start with index 1, okay? And then index 1 itself is a subarray, and max now is like -2, and then add the second element, like extending the subarray, so -1 and -2 and 1. Now the max is updated to -1, right? Let's extend it further, add -3, so now it becomes -4, but max remains -1. So we keep on extending. So how many times we extend? So we keep the pointer at the first position or 0th index, and then extend it like n times, right? And every time we just add a new value and see if my max is being updated or not, right? You see, if I do this, 5 minus 5, 0. So the max gets updated to 0. Okay, so for index 0, we do it n times. Then so this is for index 0. And then we can again start from index 1. So index 1 is 1. And then we extend it like n minus 1 times, right? For index 1, we extend it n minus 1 times. So we try 1, 1 minus 3 is -2, plus 4 is 2, right? So we keep on adding all these up to the end, right? So n minus 1 times. Then we put it in index 2, start with index 2, and then keep on adding n minus 2 elements, right? Okay, so we can do that. And finally, for last index, like the n minus 1 index, we just do it like one time. Okay, so if we add all of these, like how many total operations, you see this is order of n square, right? So in order of n square, we are trying all possible subarrays and then updating the max, and whatever the max value is, we'll get that. So that's the naive approach. Now let's think about a little bit clever approach. And for the naive approach, the time complexity is order of n square, and the space complexity, we are not using any extra space, just one variable for max, right? So the space complexity is order of 1. That was for the naive approach. Okay, so now let's talk about the clever approach. As we said, like if there are no negative values, we could just add them all, right? We could just add them all and get the thing. Now, how does the negative value changes the equation? So you can say this. So suppose we keep on adding, right? So if we add these three, you see we have like -2, -3 is okay, so just look at this one. So you see we have -1, right? We are done with this part, and then we want to extend further. Now, do you see that if we include this part and there is no value, because the thing is, so this is suppose your array, right? This is your array, and you already have like done with this part, done with adding this part, right? So there were like one element here, one here, and one here. And the value is a negative, -5. Now, tell me that if you, or think about it, if I add here, say here we have a big number, say 1 million, okay? Big number, 1 million. And even for that, do you see that it's -5 plus 1 million? Is it giving me any benefit? No, right? It's reducing 1 million. Instead of that, if we just discard this part and start over from 1 million, isn't it more promising? Like we can get more values here, right? So the idea here is we keep on adding, and whenever there is a negative, whenever the summation becomes negative, we discard it there and start over again, right? So that is the trick. So let's try to use that trick on the first example. So say this is -2, 1. Okay, so here's the thing. So -2, and also in the meantime, we will update the max value. So you see the max initially we'll just put it as -infinity. Okay, and then we will start here. We will start with -2. The current sum is -2. So the max gets updated to -2. This is bigger than -infinity, right? Then we add, okay, so -2 actually doesn't give me any benefit. So we start over again, the sum was -2. So the new sum, we start over again from here. So the new sum is 1. Max gets updated to 1, right? And then we add this. So the sum becomes -2. Max remains the same. And now we discard this part as well, because taking them in the subarray doesn't give me any benefit. Rather, if I start again, there's a chance that I will get a better value. The sum now becomes 4. We start from here, right? The max also gets updated to 4. Then the sum becomes, if we add 1, -1, the sum becomes 3. The max still remains 4. So now you see that although there is a negative value, but the sum here, 4 minus 1 is 3. Still we continue with this because who knows? Probably we'll get a positive value later, and these 3 is going to be helpful. And exactly that is happening. You see it here? So we have like 2. Now the sum becomes 5, right? And the max also becomes 5. So you see how even if there is a -1 here, still we are sustaining because the current sum is still not negative. Okay, so then we expand to 1. The sum becomes 6. Max also becomes 6. Then we go to -5. The sum becomes 1. Sorry, sum becomes 1. 6 minus 5 is, the max remains the same. Next. Okay, so we still are holding to this, right? Because who knows, if this was say 10,000, the sum would have been like 10,001, right? Or just forget it. If this was not 10,000, if it was like simply 6, the new sum would have been 7, right? Okay, but here this is 4, so the sum is 5. So the max remains the same. Max is 6. So here is the trick that we use. Let's code this up. So we'll have like a variable declared for the current sum. We set it to 0, and say result. Result becomes, we put it like negative infinity, or the smallest value of integer, not infinity, smallest value that integer can have. And then we'll check each value. So the current sum becomes current sum plus the value in index, the new value, sorry. Okay, and we'll check if we'll update the result. If the current sum has a bigger value than the previous maximum, then we'll update it, and then we'll check if current sum is smaller than 0. If that is the case, then we discard the current sum, we reset it to 0 and start over again. Or otherwise, we'll just, this won't be true, and we'll just continue with the current sum and add the new value. Okay, and finally, what we'll do is return result, which is the maximum sum. Okay, let's try to run this. Accept it, submit it. Yeah, so you see this is pretty fast, and we just ran the algorithm, like ran the for loop once, so it's order of n algorithm, whereas our naive approach was order of n square, and then we also didn't use any extra memory. We just used one extra space, which is for the result. So thanks for watching. We will come back with another problem next time.